In this tutorial, you will see how easy it is to create a smart device, a smart LED light that you can control with ChipChop from anywhere in the world. So what I've done is I've prepared a very simple device. I'm using a small ESP32 on the breadboard, and I've just connected an LED light and a resistor. So first thing is we are going to log into the ChipChop development console, and where we want to go is the devices section, and we want to add a new device. What we will be doing now is basically creating a virtual representation of our device so that the ChipChop engine knows what to expect from your device and what it can send to it. Because this is a real physical thing, not a virtual trigger, we're going to say, yeah, we're going to add a real device. So we need to give our device a name. I'm going to call this one Smart LED, and we also need a unique ID. The dev console will generate automatically a unique ID, but normally what I do is I simply give it exactly the same name as before, but all lowercase and with underscore instead of spaces. So you can use anything as a unique device ID as long as it's unique between your devices. It doesn't have to be something complex and unique in the whole world. It's just between your devices. We're also going to say what type it is. Again, that's for your own reference. This is going to be a light, and location, home, that's fine. We also need to specify the hardware. So this is an ESP32, and I am using a Super Mini, and I know that this board works absolutely fine. I'm just going to hit save occasionally. And the next step is to start adding our components. We only have one component here, which is an LED light, so I'm just going to call it LED. And as a type, we could leave it as an on-off type. It would work, but I'm going to say that it's a light. Another important thing is the operating mode. Is it interactive or view only? The difference between interactive and view only is that anything that is interactive, when we use the ChipChop app or the dashboard on this dev console, it allows us to click on the control button, and that sends a command to the device. When something is view only, this is mostly for things like sensors, where we can only view the reading. So in this case we will use interactive, and make sure to press update. If we had more components, we would just click add component and keep going like that, but at the moment it's only one. So let's save that, and then the next step is now to start programming. We need now to open the code builder. If we open the code builder from here, we will have to choose the device from the list, or we can open it from here. So this code that you see here now has just been generated when I've pressed the open code builder button, and this is now the base programming template. And one thing that we need to adjust is the first module, which is not optional. That's the actual ChipChop engine or library that will be on your device. It just needs your Wi-Fi SSID. So I'm going to use my testing Wi-Fi. And these parameters, you can also set them up. We don't need to change anything now. It's fine on default, but you can view in the module guide what these parameters mean. So let's have a look at the code. So first, what I want to do here is I need to define the control pin for this LED light, which I know I've picked pin number 4. And I'm just going to say that variable value integer. The LED pin is going to be pin number 4. And also I want to have a variable to remember the state of this LED, if it's on or off. So for that we're going to use variable LED status, and as an initial starting point when the ESP wakes up, we're going to set it to off. I'm just going to jump now. We'll come back to this part, but let's do the setup first. So all of this code is ready to go, doesn't need any changing, and all I want to do here now is I want to say that the pin mode for the LED pin, which is pin 4, is output. Like that. And also we want the LED to be off, so I'm going to immediately make sure that this LED is off. So I'm going to pull it to low, and also immediately I want to tell the ChipChop library, the ChipChop engine running, I want to inform it that our LED is actually, its status is off. And we do this by saying ChipChop update status for the component LED, and that it's off. There we go. So this will happen, this will execute straight away as soon as the ChipChop library has started, which is this part here. And as soon as your microcontroller connects to the internet and connects to the ChipChop server, it will send this information. So then you can see that immediately in the dashboard or on your phone that this LED is off. And we're going to hit save. And then we only need to add one more bit of code, and that is in this part here, the on command received. This function executes every time you press a button in the ChipChop app or the dashboard. So if we go into the dashboard now, here is our smart LED. It appeared there as soon as we've added it through the devices section, and here it is. It's not doing anything. It's waiting basically for the device to be built and connected, but this is the button that when you press on or off, when you press it like this on, in the code itself here, this will execute. We will receive the information, which component it is and what value we want this to be set up. And it would look something like this. So if we say if component equals LED, oops, this is the exact name how we've named this in the devices section. So let's recap that. LED, smart LED, it's this bit here. So this component, it's called LED, all lowercase. So if we go back into the code builder, that's what we are checking, that the command is for this component. This is very important if when you have devices with many components, you have 10 or even more, 15, then you may be interacting with them, and this is where you want to check what is for which component this command is for. So in this case, yeah, if it's LED, and then we're going to check if the value equals on. That means we've pressed the button that turns the LED on. So if this value, which is here, is on, we want to do one thing. We want to actually pull that pin high. So we're going to say digital right LED pin high, and that will physically turn the LED light on our breadboard. And then we want to say else. So if it's not on, then the command is off. And I'm just going to copy this, and we're going to say we want it off. Well, we're pulling this pin low. And one more thing, we want to change this variable now to remember the change status, but we don't have to write it here and here to duplicate things. We can simply say here that the LED status equals whatever is this value. So it will automatically become on or off. And finally, we want to again inform ChipChop, which is this bit here, if I can copy that, that we have actually done the change. So we can just say that whatever we've sent on or off, oops, status, that's it. So this, if we press the on button and the value was on, this will basically say update the status for the component LED to on, or if it was off, to off. And that would also reflect in the development console, in the dashboard, or on our app. That change will show. And this is it. I'm going to hit save. We don't need anything else. That's all the code you need to create a smart LED. So next step is to download this code either in Arduino IDE format or Platform IO. I'm going to use Arduino IDE, so I'm going to press save. This has now downloaded the code, and if we look, here it is in my downloads folder. We have a zip file called Code Builder Package, and if I unzip this, we have inside the zipped folder, we have this folder Smart LED. You also have instructions that you can read. Normally there won't be much going on here unless you want to you're using some of the modules that require installation of some libraries. But as a general rule, this folder now contains everything the code builder has prepared for you. And on this screen here, I have in my documents, here is the Arduino folder, and that's the standard Arduino projects folder. It's most likely going to be exactly the same on your computer, PC, Windows, Mac, Linux. It lives in the same place, and all I have to do is drag this into that folder. That's it. So now we can open Arduino IDE. Here we go, and if we look here, we can now see this project, and we just need to open the Smart LED inner file. So make this bigger, and now we need to select our board. I've plugged my ESP already, so let's have a look. Super Mini, here we go, and it's on this serial port. Pretty sure, yes. And now I'm going to do a quick compile to make sure that it's all working, that we don't have any bugs in our code. And here it is, compiling is done. There are no errors, so we can now push this onto the device. Great, so this is now uploaded onto our ESP, and I'm going to open the serial monitor, and it's already connected. What I'm going to do now is I'm just going to physically press the reset button on the ESP, and you will see what happens from the start. So here we go. So it's connecting, Wi-Fi connected. It's now it's getting a handshake request. Connection is accepted, and it's going to start sending heartbeats very quickly. Here we go. And it's already sending the heartbeat, the LED off. So this is the bit that we said in the setup. Here it is, ChipChop update status, LED off. So I'll try to show you at the same time on the screen Let's make this a bit smaller. Both screens, so we have now, we can see what's happening here, and this is our dev console. And if we go into the dashboard and we click on the smart LED, you see it's showing already that it's online. And when I press the LED on button, you can see here that it's received the command LED on, and now the heartbeat has changed to LED on. And if I say LED off, the heartbeat is now changed to LED off. And that's it. This will work now from anywhere in the world. And I will show you what it looks like when it's used on the phone. And here it is. We're using the ChipChop app to turn the LED on or off. That's it. Hope you've enjoyed this, and good luck making your first smart LED.